All right, so today we're doing science and we're going to be focusing on, we're going to become engineers today. So just to start it off, I'd like to remind you of the engineering practices. These are the things that make someone into an engineer. So one, engineers defining problems. Engineers ask questions to make sure they understand problems they are trying to solve. They need to understand the constraints that are placed on their designs. 2, developing and using models. Engineers develop and use models to represent systems they are designing. Then they test their models before building the actual object or structure. 3, planning and carrying out investigations. Engineers plan and conduct investigations. They need to make sure that their designed systems are durable, effective, and efficient. So these 3 engineering practices, 1, defining problems, 2, developing and using models, 3, planning and carrying out investigations, we're going to be coming back to them later. 4, analyzing and interpreting data. Engineers collect and analyze data when they test their designs. They compare different solutions. They use the data to make sure that they match the given criteria and constraints. 5, using mathematics and computational thinking. Engineers measure physical properties. They use computation and math to analyze data. They use mathematics to construct simulations, solve equations, and represent different variables. 6, designing solutions. Engineers find solutions. They propose solutions based on desired function, cost, safety, how good it looks, and meeting legal requirements. 7, engaging in argument from evidence. Engineers use argumentation to listen to, compare, and evaluate all possible ideas and methods to solve a problem. And last, 8, obtaining, evaluating, and communicating information. Engineers must be able to communicate clearly. They must evaluate others' ideas. They must convince others of the merits of their designs. So that might not have been the most fascinating thing, but it will help you later with this reading. So let's jump into today's reading, which is thinking like an engineer. How did you decide what circuit is best for a string of lights? You learned about the problem. You looked for ideas about solving it. You were thinking like an engineer. So here's an example of engineers solve problems. So what do engineers do? Engineers solve problems such as how to make or fix something. First, engineers define the problem carefully. They decide on the criteria for a good design. This means finding out what the solution must deliver. So again, I mentioned this before, but we'll be coming back to this at the end of the reading. Number 1, defining the problem. So an engineer is looking at the world around them and looking for problems that might need to be solved. Here are the criteria for the string of lights. All the bulbs are brightly lit. When one bulb burns out, the other bulbs stay brightly lit. Engineers must also consider constraints. So this is part 2. The constraints are the design limits. Here are some constraints on the design for the string of lights. The materials are easy to get. The string is inexpensive to make. It is safe for people, pets, and the environment. So here's the photo of the string of lights. I'm sure some of you have seen these before. And you need to think about the criteria and constraints when deciding what circuit to use for a string of lights. Next, engineers design solutions to the problem. They gather materials and tools. Then they build and test a prototype. Does it meet the criteria of a good design? Often, the solution does not meet all the criteria, so the team revises the design. They always consider the constraints. Is the solution inexpensive? Are the materials easy to get? Is it safe and easy to use? So here are the elements of the engineering design process again. I personally like the first page better, but here it is again. Let's review the process of engineering design. 1, understand the problem thoroughly. So you got to understand the problem. 2, define the criteria for and constraints on a solution. I find that a little confusing, so we'll come back to that. 3, plan a solution. And so this is where I think most of you would have to stop if you're doing this at home. Of course, if you could keep going, go for it. Because 4, build the solution harder when you're at home and you don't have so many supplies. 5, test the solution and evaluate its performance. 6, revise the plan based on data from the test. 7, repeat steps 4 to 6 until the solution satisfies the criteria and constraints. 8, obtain a patent and go into production, which is kind of funny that they added that in. You'll see these yellow ones. These are the same as over here. And we'll come back to this at the very end. But I like the way they set this one up a little more. 1, defining the problem. Very clear to me. Excuse me. Yeah, I like this version better. 2, develop and using models. 3, planning and carrying out investigations. So we'll come back to that one at the end, but there is one more page of this reading. A better light bulb. Think about Thomas Edison, 1847 to 1931, working on the light bulb. The filament burnt out too quickly. His team developed a plan to solve this problem. They made hundreds of different prototypes and tested them. Think about the criteria for a solution to this problem. How do you make an inexpensive light bulb that lasts a long time and uses little energy? Edison and his team found a good solution. Ever since, engineers have been designing light sources that meet new criteria. What would the criteria be for a portable lighting system used in places without electricity? What would the constraints be? Computer engineers work on designing new computer systems. So this lesson might have been a little confusing, but if you have your yellow notebook or a piece of paper, let's give it a little try together. I want us to focus, use the engineering practices that are over here. We're just going to do numbers 1 to 3. So let's write down the title, Engineering Practices, as the title, and the date, April 6, 20. And I'm just going to copy these down quickly, and you can pause the video to write them with me. So 1, defining problems. And I'm going to give myself 3 fingers of space in between here before I write number 2, which is developing and using models. And again, I'm going to give myself 3 fingers here. I'm just going to move this aside. Planning, 3 fingers, 3, planning and carrying out investigations. Okay, so this is a time for you to get really creative here. And I want you to be thinking first, defining problems. What kind of a problem, an engineering problem, might you be having? For example, you might want to be reading really late at night, and how are you going to read in your bunk bed, but not disturb your auntie or your brother or sister who you might be sharing a room with? You know, I'm just going to draw that for you right here. I'm in my bunk bed. Here is my older sister, my little sister. This sleeps up here, okay? This is sister. And here I am in my bed. And I want to read a book. I want to read a book. And I need a light. So that was not a great drawing. Too bad. But I'm thinking, so if I want to read my book, how am I going to get light on it? So I think the problem would be, here's a problem, which would be night light for my bunk bed. Okay? There's one problem. Okay? And if we have a problem like that, what are the solutions? What kind of models, developing and using models, might we need? I would like to remind you of this one thing that was mentioned here, which is define the criteria for and constraints on a solution. So I would recommend here that you come over here and write, so what might be some problems you might face? Maybe there might not be electricity, no electricity in your bed. So then, but a positive is maybe you have a flashlight at home. Okay, but if you have a flashlight, you might not be able then to, how to hold the flashlight and read. So then maybe you have some tape. Oh, and maybe you also have a string at home. So maybe you could then hang the flashlight. I'm just making stuff up here. I was also thinking, yeah, so I mean, if this is the flashlight here, where am I? Can you see my drawing? If this is the flashlight, okay, here's the light. Could we tape it? Could you hang it from the ceiling of your bunk bed? And then you can read your book. It's just an idea. Okay, so this is me developing and using a model. I'm noticing, okay, we have no electricity in the bunk bed, but we do have a flashlight. Can we hang the flashlight with a tape and a string? And planning and carrying out investigations. So this is something that you